Hello, everyone, and thank you for joining. Welcome to our webinar about Clean as You Code, a proactive approach to technical debt. In this webinar, we will go over the trial and tribulations of dealing with technical debt and present you with a sustainable approach to not just effectively manage your existing technical debt, but also preventing a future one from accumulating. My name is Bianca. I'll be your moderator for this session, which will be presented by Vivek. Speaking of Vivek, Vivek is a product manager at Sonar. He has more than a decade of experience in static code analysis and code quality under his belt. And his experience in a wide range of industries gives him a very holistic perspective on creating solutions for clean code and handling complex challenges such as technical debt. So needless to say, you are in excellent hands here. Now, before we move on, allow me to very quickly go over some essential housekeeping items. First of all, this session will last for 45 minutes, and those 45 minutes include the questions and answers at the end. In the course of the webinar, you will be invited to submit your questions via the Q&A box at the bottom. Mind you, do make sure that you submit them in the Q&A box, not in the chat box. And additionally, we do have two fantastic panelists behind the scenes who are going to be answering your questions live during the webinar. That is Alexander from our product management team and Robert from our product marketing team. For those of you who have already asked this question, this session will be recorded and we will send you an email in the next couple of days with the recording as well as the questions that were asked during the webinar. Finally, at the end of this webinar, you will see a short survey that will pop up on your screen. We will greatly appreciate your feedback, so thank you in advance for your participation. Now, I will not steal any more of your time, and without further ado, let's dive into the session you're all here for. So, off to you, Vivek.
Thank you very much, Bianca. I'm extremely excited to talk to you all about Clean as You Code today. Hello to all of you. So, first of all, let's see what will we cover today. Well, when we talk about technical debt, there is two camps generally. And the first one is technical debt is high, and let's do some debt addressing sprints to bring things under control so that we can develop some features after that kind of camp. It's kind of a sad camp, as you can imagine. And then there is a happy camp. That is, technical debt is under control because we have a sustainable process. Obviously, very happy camp there. Now, what we are going to discuss today is how to take people from camp 1 to camp 2, wherein we all can be happy when we deal with technical debt. And how are we going to do that? Now, doing that will typically mean answering some questions as usual. Well, I would start by saying smart way to fix issues is not to fix everything. Stay with me. Now that will you will think that that is counterproductive. However, how can we make sense out of this statement that let's not fix everything? Now, to do that, we need to answer the question, why are we fixing issues anyway? What is the motivation behind fixing for all of us? Because there are some straightforward answers for this, but it is very important for us to set the context by understanding our motivation behind fixing all these issues so that we can craft the perfect way to actually address technical debt. So, why are we fixing issues really? Now, there are some very common answers that will be popping up in your mind at this point. Security issues. To avoid security issues that can cost your business money and reputation. Of course, everybody wants to fix security issues, no questions asked. Usually this is one of the highest priority and obviously so. No questions there. Then there are reliability issues. Why do you want to care about reliability issues? To make sure that the application is performing as intended. Its functionalities are working as expected. Because if it is not, then the software is not doing the job it is designed to, and it is not providing any value at that point. Therefore, you may want to fix all the reliability issues as well. If you see these security issues and reliability issues fall under the category which we can broadly classify as operational risk management, you want to make sure that the business is operating risk-free because of this. Remember, the reliability issues can be really problematic in the way it can be really fatal as well in some cases. So you want to really take care of these two categories of issues. You are very sure about this. However, what about the larger number of maintainability issues? We often ignore maintainability issues because they are not directly thought of as something that can be problematic like security or reliability issues. But we ignore them at what price? Well, lower velocity of development. We will ship less number of features. Extending existing features are very slow. New developers take more time to onboard and so on. That means when we add maintainability issues to our code base in the immediate future, our engineering team's development velocity or delivery velocity is going to suffer. We are overlooking this fundamental fact a lot of times when we think about a strategy on how to address technical debt. This is very important because on long terms, it is very important for engineering teams to be optimized. We will see in a moment. And there is one more reason why we need to address maintainability issues. With a lower maintainable code base that is accumulating a lot of maintainability issues, it can be also correlated with another situation wherein it can result in more security and reliability issues as well. What I'm saying is, with increased reliability issues comes the risk of having more security and reliability issues as well. Therefore, it is an investment on our part to actually take care of these maintainability issues in the long run. Therefore, we can have happy developers because it is easier to extend features, it is easier to understand, it is easier to onboard new developers, etc., etc. Plus, we will have less security and reliability issues probably in the future as well. Therefore, now we know fixing issues, the motivation behind fixing issues is not just about mitigating risk and operational risk, but also saving time, effort, and money for the business while doing it in the long term. And when I'm talking about long term, it is not just long term. In the immediate future, taking care of maintainability issues in the new code, in the code that we write in the recent time, will start giving dividends in the terms that you will start seeing higher velocity from the engineering team. So therefore, now at this point, we clearly know why we are fixing issues, what kind of benefits addressing different kinds of issues gives us. Therefore, we should not ignore one kind or the other. Now, so we know the real goals behind fixing issues. So should we stop everything and fix all these issues that is detected by Sonar products so that we can be faster afterwards? That means we will fix all the issues detected and then we will go develop features. Is that a viable option? Well, I will restate this. Smart way to fix issues is to not fix everything, right? Please remember this point because that is our story today. Smart way to fix issues is not to fix everything. Now, let's see what happens in real life, right? I have taken an example with Apache Hive. If you look at this, I have taken a screen grab from Sonar Cloud to see what is really going on. We have 90 security issues. We have 1,600 reliability issues. There's plenty of reliability issues there. And over 44,000 maintainability issues. Let it sink in. You see a lot of issues here. However, you have probably seen similar case with your projects as well. Lot of issues. And this will raise questions in your mind. Is this kind of tools really usable? What am I supposed to do with such huge amount of technical debt? You ask how huge the technical debt is. Yes, it is over 780 days of effort to fix all of those issues. Well, okay, that is too many issues and too much time is required to fix all of those issues. And obviously, when such situation comes, what we do as humans, we prioritize, right? For example, if we have so many tasks, we will think, okay, which are the most important ones for me so that I can prioritize those issues and work on them first, because that will give us the most return for our investment. We can apply the same principle here. Can we fix just the highest priority issues? Now, how will we prioritize issues? For example, we can look at severity in Sonar Cloud, for example, and we can take the highest severity examples, and you will be still left with a lot of issues. So let's hold that question for a moment. Should we prioritize issues? And that is the perfect time for a poll. When you have so many issues in your project, just like this, in your overall code, you have so many issues. What would you do usually when you are encountering such a situation? Well, we have few options here. We fix everything. We may take a couple of years, but we will fix all of them, and then we will develop features. We prioritize all severity or issues by severity and fix most critical issues, just as we said, the prioritization. We fix all vulnerabilities and leave the rest for now. We fix security issues, or we keep calm and clean as you code. I'm really interested to see what would you do. Let the responses come in. Excellent. Well, I'm really pleased to see this result. And let's start by saying a lot of you are saying we keep calm and do clean as you code. That is really amazing to see. You are already on the right path. It's really pleasing to see that. And obviously, a lot of you have responded by saying we prioritize by severity and fix most critical issues, because this makes sense, right? This is the common way of doing this. So it makes perfect sense to do it this way. I understand it, but you are going to find this way today that is clean as you code, which will be much better than your current approach. So let's continue on our understanding journey with this one. All right. Um, so just analyzing that issues a little bit more here. We have over 96% of our issues in Apache Hive that are actually older than 1 year. And how much time you might take to fix them all? Over 750 days of work to fix those 96%, over 96% of that issues in issues that are really old. Now that raises a question, should we really fix these older issues? Now, we are going to continue exploring and finding that answers. Now, I mentioned 1 year, like the remaining 3.5% of issues are from the last year, right? Detected last year. Now, with that, let's see why prioritization is not the best strategy. A lot of you have said, let's prioritize and let's fix those issues that are higher priority, right? Now, for a moment, imagine that this big blue box is the overall code, maybe for Apache Hive or any other project. Now, there are a lot of issues in this overall code, right? There is There's plenty of issues. In this case, over 750 days worth of work of issues in this overall code. Now, should we fix all of those issues by prioritizing? Let's see in a moment. And you see that little pink patch, that is the code changes made last year. Let's assume that is a small area where we are making code changes last year. And there are obviously some issues lying in that new code as well. Well, what does that all mean is that if you are going to fix some prioritized issues in that overall code, which is the bigger chunk of code, right? We are going to get limited benefit from fixing issues there. Why? Because our developers are not going to touch those dormant code. Therefore, having more clean dormant code may not accelerate our development process in any meaningful way. So we will get more benefit, more return on our investment if we fix issues on that pink patch. That is our fresh new code. I mentioned 1 year. However, what if we focus on new code? The term new code is very important here. And it can be something different from 1 year, actually. When we develop software, code is added incrementally, isn't it? We make new code increments and add to our existing code base batch by batch over time. This is how we develop software. And if we just focus on the quality of such new code increments, we can ensure two things. We are just focusing on the quality of that new code increments. We make sure every new code increment is clean. One thing that we attain by doing this is no new debt is added. That means we stop adding new technical debt to our repository altogether because we are making sure new code is always clean, right? All these new code increments are clean. But there is one more benefit that we often forget that we get with this approach. That is, most important parts of old code is also getting cleaned gradually. Why? Because when we talk about new code in Sonar products, it includes two things. One is added code, second one, modified or changed code that lies in the old code. You may take, or your team members may take some file that is in old code, may modify a little bit, but with clean as you code approach, when you touch some old code, you clean that piece as well. So simply by practicing clean as you code using Sonar products, you not only clean the newly added code, you also clean old code that you are modifying. So the practice with this is very simple. How do we apply this new code increment cleaning process? It's very simple. You write code, and that is your new code, and you scan that new code with Sonar products, and then fix issues when it is reported, and continue the cycle move. That is very obvious, Vivek. Yes, it is obvious, and it is super simple, but we will see this cleaning process in a little bit more details so that it will sync better. Now, when we are practicing this clean as you code, when we talk about this new code increment, what developer is supposed to practice? Yeah, the thing is very simple. We have this new code increment. We need to make sure that quality gate is passing. That is, quality gate is green. That will make sure we have a clean code increment, that is zero issues. But that actually means resolving all issues as early as possible when they are reported. Now, resolving an issue primarily have to be done by fixing them. It makes sense, right? And then you can accept issues if you don't want to fix some of those issues at this point in time. We should use this option responsibly, because by accepting an issue, you are adding technical debt to the repository. So if you use this option, I will strongly recommend you come back and fix those issues at a good time. Now, finally, you can mark false positives as such. And at this point, with these three options, you make sure you resolve all issues in the new code. And therefore, our new code increment is clean. In other words, new code increment is conforming to the standard defined by your organization. Therefore, it is clean. And That is the process the engineer have to follow. Now, clean as you code in 3 stages. Clean as you code as a process have 3 essential stages or layers in practice, and all of them are very important. Let's go through each of those layers one by one to better understand what is really happening. So the first stage is in IDE. In IDE, we have Sonar lint present. So the developer is writing some code in his personal space or her personal space. This is what we call a new code increment in the ID. Whatever code I am writing, but that is not yet committed, is my new code increment. And we will scan it with Sonar lint. And by doing so, we make sure that, okay, whatever issues reported, we fix those issues. And thus, we are confirming to the standard because, we are using connected mode in Sonar lint, and it allows you to sync with your defined standard. And when it is really clean, that is, this new code increment is clean, the code is ready to be committed. That is the promotion at this stage. Well, that is stage 1. Now, what is stage 2? Stage 2 is where you make a pull request. You open a pull request, and whatever code change is happening or happened in the pull request is the new code increment in the context of the pull request, or rather pull request scan, let's say. And here, as you can imagine, Sonar Cloud or Sonar Cube will help you scan your new code increment. And you have to make sure after the scan, the quality gate on that pull request is passing. Well, if you have issues, obviously you have to fix those issues or resolve those issues to be more accurate. And at the end, the pull request is ready to be merged. You can see in stage 1 in the IDE, developer was the only person involved in this contributing to the new code increment. And when it comes to pull requests, there are a few more people, few more team members involved because the PR have reviewers, probably somebody else, some colleagues are looking at it. So that is your stage 2. Now let's see what is stage 3. Can you make a guess what is stage 3? I'm sure some of you will definitely do, and it is the branch scan. When multiple teammates are contributing to a branch, right? It is not just few people. Now, there are contributions from all teammates, all developers coming together to a branch. Now, that is new code in the branch, but coming together how? In Sonar products, we have something called new code definition. You can define what is new code definition, and it may be based on your team's context. I will, in a bit, explain more about that. But it segments, it defines, and it helps Sonar products to identify your newly added code in the branch as new code. And again, Sonar Cubes or Sonar Cloud scans your new code. And again, you have to fix issues until your quality gate is green. It is passing. Now your branch is ready for deployment. Now see, you have 3 different stages to clean as you code. Now you may ask, all right, why do we need all these 3 stages? Can't we just get away with doing the pull request scan? Or maybe why we need all these when we are using Sonar lint? Well, Sonar prioritizes speed of analysis towards left and depth of analysis towards right. Why we do this? Because as developers, we need faster analysis results in the IDE, in the pull request. Therefore, in the IDE, you will get within seconds, you will get this analysis result. In pull request, within minutes, you will get the results. That way, the results are usable. If you are getting PR scan results in 1 hour, it's barely usable, I would say. So therefore, we had to prioritize speed towards the left. However, by having the branch scan, we can completely be sure that our new code increment is free from all kind of issues. That is the depth of analysis coming into play. Well, now you see why we need all 3 layers or stages of clean as you code and how they work. Now, let's see how to implement clean as you code in your organization, in your team, or in your project, there are few steps that you have to take in practice based on your persona or your job title. Some of these steps will be applicable to you. Now, let's see what those steps are. First of all, you will have to define quality goal or your clean code goal or the standard that your organization want to maintain on your code. And for this, you can use quality profile and quality gate. And with quality profile, you will list the rules you want to enforce. And with quality gate, you will define your quality criteria that is to be met by the new code increments. Now, this will be important for the quality committee you may have in your organization or the people who are actually managing the quality of code standards for your organization. Now, the next step here is define new code for branches. Sometime before I mentioned about ability to define new code. What is new code in a branch? So in Sonar products, we have ability to define new code. What is new code? For example, you may choose something like, okay, everything after last release should be treated as new code. Maybe your team is making a release every month so that SonarQube can automatically detect any code written after that version bump as new code. Or maybe if you are doing continuous delivery, you may want to use something like number of days. You can set a value up to 90 days and SonarQube or Sonar Cloud will detect new code based on that. There are different options available for new code definition, and you should choose the best option that works for your development team's context. I will recommend you to take a look at Sonar product documentation to see what works best for you. Or at the end of this webinar, I will share you a very interesting resource that will help you choose as well. Now, this is something an engineering lead, engineering manager will have to take care of for their team. After that, we have to ensure regular scan is happening. If you have done set up the goal, we have defined what is new code that will help SonarQube to identify new code. We still need something more. We need to enforce scans in all three stages. First of all, we need to make sure that every developer is empowered to use SonarLint in connected mode to take advantage of this stage of clean as you code. We need to ensure this. And then to have DevOps integration so that pull request can be done effectively in your project. So DevOps integration is important. And finally, for the last stage of clean as you code, you need CI integration so that a routine scan is happening on your branches. So these are something your engineering operations team can handle and make sure your project is scanned regularly in all three stages of clean as you code. Now, with that, the setup for clean as you code is ready and it is good for the final stage, that is where engineering practitioners or the clean as you code practitioners come into play. All new code increments meets quality standard. For that, you will just make sure that clean as you code quality gate is always green. The quality gate is green means your new code increment is clean. And when you ensure this simple thing in all those three stages, you are on the path to clean code. Well, that is our implementation steps when you adopt clean as you code practice. Now, let's take a look at what would have happened if you have focused on the new code in the Apache Hive project. You would have just 107 issues and a little bit over 1 day worth of effort to fix issues. That is not just manageable, that proves that this methodology, the clean as you code methodology, is sustainable. You can keep doing this all the time. Now, in this particular example, this project have 90 days as new code definition. If you are wondering, these 107 issues are accumulated in 90 days in this case. Not too much. See, it's really manageable. Now, let's see what are the benefits of practicing clean as you code that can bring practically to your engineering teams. Well, we focus only on new code and edited code. So developers are going to be happy. because they don't have to really work on ancient code written 15 years ago by somebody else, try to understand that, no longer do that. Now we focus on code, and there is code ownership now because I have to work only on the code that I or my team have written in recent time. Stay happy. And organically prioritize most important issues. What do you mean by organically prioritizing, right? When you are changing old code, you are also fixing issues in the most important parts of old code. You see how Clean as You Code is prioritizing most beneficial parts of old code naturally, organically. That is really cool, I would say. And then you don't have to worry about, am I fixing the most important old issues or not? You are when you are using Clean as You Code. Any code added from now is clean. Basically, you fix the leak. No longer you're adding any more debt. Your software remains an asset. By doing this, fix the leak, you make sure that your software is remaining an asset, not a liability. Easier to extend your code base from now on and faster team onboarding because your recent code is very clean. So your developers are really happy to work on it, and new developers coming in find it really easy to understand this recent code. Therefore, they can onboard faster. No more debt addressing sprints because you no longer need them because your debt situation is under control. Therefore, your team can actually focus on feature delivery. Therefore, improved feature delivery velocity can be achieved by the engineering team. Well, that is exactly what you will get practically by using Clean as You Code. Now, let us recap this quickly. Clean as You Code is the most efficient path to clean code. Now, clean code is what you define as your goal for your organization. This is the minimum practice every team should have. Why am I saying this as the minimum practice? It works for all kind of projects. It works for legacy projects that is written 20 years ago. It works perfectly for a brand new project that your team is excited about. It works in every single project. In case you have some goals over and above Clean as You Code, you want to pursue some goals on the overall code, you can obviously still pursue them as complementary to Clean as You Code. Now, therefore, Clean as You Code works for every team for sure. Therefore, I will recommend you adopt this methodology today. And to do that, now there will be a link shared to you. I will recommend you go check that out, see how to get started with Clean as You Code. You can see how to actually set it up in the product and get started with it. With that, over to you, Bianca. And before that, thank you very much for listening to me.
Thank you very much, Vivek. That was truly a great presentation on a rather challenging topic. And may I just say that I'm actually very pleased to see how many of our attendees are actually cleaning as they code. So rock on, guys. This is truly the most effective way to use Sonar tools. Now, before we move to the questions and answers portion of our webinar, I briefly wanted to share a couple of things with you. First of all, look, more webinars. So in the upcoming weeks, we have two more interesting webinars. The first one is on June 6th. If you're a .NET developer, and even if you're not, and if you want to know more about security in a web application, join our .NET team alongside with a Microsoft MVP. And if you want to know more or everything about Sonar Cube, join our extremely knowledgeable community manager, Anne, on June 12th. You can register today for these webinars. You will get the links in the chat right now. As a reminder, a short survey will appear after our questions and answers session, and we will greatly appreciate your feedback. Now, before we move to the Q&A session, on your screen, you'll see a brief poll to indicate if you would like to learn more about our solutions. So let's just take a few seconds to answer. Seeing quite a lot of answers. Looking good. Okay. Let's just squeeze some more responses. Okay, perfect. Thank you very much. Okay, so Vivek, looks like we have some questions that needs to be answered.
Wonderful.
So let's get started. Okay, so what tends to be the most widely used? This is a really good one. The most widely used clean as you code duration, for example, 30 days, 90 days, 180 days.
So 30 days is super popular. If I remember right, 30 days is the most popular one. And the other one that is really popular is using the previous version as the version bump will help you automatically detect new code period. So it is a very popular option among our users. And it may be even better than using number of days there because this way is really automated and no issues can slip out of your new code period.
So basically use clean as you code all the time.
Oh yes, yeah, and yeah, previous version that is pretty much the most suitable and most popular option right there.
Okay, so there's another one. What if we have critical issues such as security vulnerabilities in the overall code and we care about fixing those? How do we go about that?
Well, this is very important to understand. You are totally okay to pursue goals on overall code, such as addressing vulnerabilities and bugs on overall code is very important. So what we can do is that we can add conditions on overall code in quality gate to make sure that we are covered there. And this will still keep your quality gate suitable for clean as you code. And you are still covering your goals on overall code. So what are we doing with this? We are basically doing these goals on overall code as complementary to clean as you code. You're doing clean as you code as the fundamental process, then you have some additional conditions that will make sure that your goals on overall code is also covered. So clean as you code is not the solution for overall code or every special use cases for your organization, but it is the minimum process everybody should have. And on top of that, you can add complementary processes using the flexibility available in our quality gate, basically.
Perfect, thank you. Okay, thanks. There's a lot of questions popping in. Another one for you, Vivek. We cannot achieve high coverage or duplication as recommended by the Sonar Clean as you code methodology. So what should we do in that case?
Excellent question there, Bianca. Yes, we understand this, that coverage and duplication is two areas where you may not be able to achieve a very high degree or threshold in your project. Because of this, we kept it such that you can tune these two conditions in a clean as you code compliant quality gate. When your quality gate still remains suitable for clean as you code, you can change the slider, you can change the coverage to suit your team's need. Similarly, you can adjust the threshold for your duplication as well in the new code. These two conditions can be adjusted as per your requirement in a clean as you code compliant quality gate. Other conditions cannot be because you have to be strict about them. In these two, it is important to have that great flexibility for each team. That way, clean as you code methodology can be used by more number of teams realistically. So we kept this flexibility for you.
Okay, thank you. Another interesting question popped in. Could we apply the clean as you code methodology in just one stage, for example, in the IDE?
Well, this have two answers. First of all, I will recommend having all three stages down. This way you make sure that new code increments are absolutely clean. And if you're not using one stage, you are missing out a little bit on that insurance. That said, if you're getting started with clean as you code methodology, it is totally fine to start with one stage and then ramping up to stage two, stage three. It's great. Start with one stage and then go to the all stages. That's it. If you have the ability to have all three stages, it is important to have all three stages to have maximum efficiency of early detection as well as deep detection in branches, so that you can make sure that your new code increment is absolutely clean. So simple answer is yes, you need all three. But to get started, start with one stage and don't worry about having all three at the beginning.
Great. Okay, we have time for one last question. And this one is about Gen AI. How does generative AI for code assist helps with clean easy code, like GitHub Copilot, so on and so forth? What is Sonar's source Gen AI strategy?
Well, here, what I can say is at least that we understand that there is a lot of AI generated code in your code bases. Right now, it is already there and it is going to be more in the future. However, Sonar products will make sure that your generated code is clean. You want to make sure that your generated code is clean, right? You cannot trust blindly the generated code. That is where Sonar products comes in and make sure that your generated code is also clean from big risks and maintainability issues as well. So you still need Sonar to cover this, and there may be more, but this is the most important thing I can share at this point about you know, the AI generated code and how Sonar products will help you cover there.
Okay, so in a nutshell, whether it's man-made or machine generated, just use clean as you code. Is that your words of wisdom to our audience?
Absolutely.
Perfect. Okay, so I see that our panelists are still answering questions. In case we can't answer all of your questions, in a follow-up email to our community post, we will share all the questions that have been asked and answered, and we'll continue to answer them. Now, first of all, thanks, Vivek. That was an absolutely fantastic presentation, and thanks for all of you that posed questions. Again, our community is a great place to post further questions and review the ones that were already asked during the course of this webinar and that were answered. Please do visit sonarsource.com for further information on how to use Clean Easy Code and check out the information on future webinars. And again, thank you for providing us with your feedback. And that will, it will shortly pop up on your screen. And see you all soon.